Now I'm going to vary slightly from the way that the book explains law of cosines because I think there's an easier way to remember it. What we want to accomplish here is we want to use the law of cosines to solve those two other cases that we've got, if we know all three sides or if we know the side angle side scenario. And then once we've done that, I'm just going to flash some triangles before you, and I want you to decide, would you use law of sines or law of cosines to solve the triangle? We'll do that right at the end. Now, here's what the law of cosines says. And again, we're not going to prove this because the proof is shown in your book. We're just going to use it. Now, that's a mess. That's how your book explains the law of cosines. It says for any of the three angles that you might be working with, for example, the top one, the square of side length A is equal to the square of side length B plus the square of side length C minus 2BC times the cosine of angle A. Yuck. You going to remember all those cases? I wouldn't. But it works out. It's true. Now notice, take out your calculator for just a minute. I want you to notice one particular case here. Let's just look at the bottom one for a minute. C squared is equal to A squared plus B squared minus 2AB cosine C. Let's make a triangle. I'm going to draw a particular triangle. A right triangle specifically. Yeah, good enough. I'm going to make C a 90-degree angle. Take your calculator. And, well, you really don't need your calculator, but what is the cosine of C for this particular triangle? C is 90 degrees. What is the cosine of 90 degrees?
0.
It's 0. So if we take the law of cosines and apply it to this triangle where C is a 90-degree angle, this becomes C squared equals A squared plus B squared minus 2AB cosine of 90 degrees. But you just said that that is 0. So what happens to this whole last term on this expression? It becomes 0. So what are you left with if C is a 90-degree angle? You're left with the Pythagorean theorem. Okay? So you can think of the law of cosines as a variation of the Pythagorean theorem that takes into account that C might not be a right angle. If C is a right angle, that's true. If C is not a right angle, this extra term takes care of it. And it provides that relationship. But we need to know what angle C is if it's not 90 degrees. Here's the method that I use to remember the law of cosines. Instead of remembering A, B, and C, we're always going to have one angle that we're interested in. Either it's the one angle we know or it's the one angle we want to find. And from that angle, we'll name the other three sides relative to that angle. Now, you won't find this in your book. This is sort of a made-up system that is a little bit more efficient because it's one thing to remember. But for example, in the picture, from our angle theta down in the bottom right, one side is to the left of that angle, the other side is to the right of that angle if you were standing there, and the third side is the one opposite that angle. And it's always true that the opposite side squared equals the left squared plus the right squared minus 2 left right times the cosine of your angle theta. That's the one that we're going to use. It's important to note that there are 6 possible cases for triangles where we're given 3 pieces of information. Which one can't you solve? There's one way you can be given 3 pieces of information you can't even solve for the triangle. Which one is it? Angle, angle, angle. You can't solve. You have to know at least one side. We use law of sines for side, side angle, 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 side, and angle, side angle. That leaves these two, and law of cosines will take care of both of them. We can solve side, 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 or side, angle, side scenarios. So let's do an example. Which one of those scenarios have you got here? This is a side, angle, side case. Here's where your text says that you have to choose the A, B, and C according to what you know and what you don't. Forget it. Let's just use the left, right, opposite method. So 103.2 degrees is our angle. It's the only one that we know. So what is the value of our opposite side here? We don't know it. It's lowercase b. Right. So we know that the opposite side squared, which in this case is b, equals the left side squared. Now what's the left side relative to this angle? If you were standing there, what would the value of the side to your left be? 15.45. You'd be up here looking this way. Left would be 15.45 squared plus the right then has to be 16.75. You'll notice by the nature of the equation that if you get them mixed up, it really doesn't matter, as long as you're consistently mixing them up. Minus 2 times the left side of 15.45 times 16.75 times the cosine of 103.2 degrees. It is, but there's no algebra to do. It's all calculator work. So, just a tip for you, it's usually easier as far as the keystrokes on your calculator are concerned to do this part first. Okay? So do this part first, and then you can usually add on 16.75 squared and 15.45 squared just with a couple of keystrokes. So take cosine of 103.2 times 16.75 times 15.45. Make sure you're careful with the sign. This is the most common error with law of cosines, is mixing the sign up. Times negative 2. Add 16.75 squared plus 15.45 squared. Anybody verify that? Else verify 637.454? Okay, that's better. I don't know what went wrong there. I'll mark that wrong and fix it later. Well, then we can just take the square root, and we know that b is equal to 25.25. Good. I had that part right. 25.25. So we know our opposite side now. Now we know all three sides. Now, once you use law of cosines once, no matter what scenario you've got, you're going to have now the opposite side in the angle. So there's no need to use law of cosines anymore. This is a lot more math, as Steve pointed out. There's a lot more math. Law of sines is a simpler rule. So now to go ahead and find these two angles, you just jump over and use law of sines. Okay? Before we do that, any questions about finding b, or is that okay? You should never, you could, but there's no need to ever apply law of cosines more than once. Grant? All right, well now let's use law of sines to solve one of the others. Let's just, which one did I do? I did C, so let's just do C here. I know how that one works out. We know that the sine of 103.2 over 25.25 that's got to equal the sine of C over 16.75. We've done that quite a bit now. I'm just going to tell you, though suddenly I feel like I should be double checked here. C should turn out to be about 40.2 degrees. Good. 40.2 degrees for C, just using the same rule that we've done and that you're becoming experienced with. So now we know that. And then you have practically nothing left to do. You know all three sides, you just need that one angle. You can subtract. 180 minus the 103.2 minus the 40.2 degrees turns out to be 36.6. Yep. And we've got it solved. Though there is more math involved, there's no ambiguity. Law of cosines will always work out correctly. There's no question of whether there's one or two triangles. Side, 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 or side, angle, side, both define triangles. Okay. Let's solve this triangle. We know none of the angles. This is the first triangle we've seen where we don't know any of the angles. This one's on the little sheet that I gave you. The print is a little small. Well, first you have to decide which angle you're going to find first. Which angle should we find first here? E? Oh, E. B, C? Doesn't matter. Doesn't matter. We can find any one, okay? Since we know all three sides, there's no good reference point. So just arbitrarily, let's find A.
Just for equation-wise, since you have the B on the left side already,
Well, the book gives all three equations, A, B, or C being isolated. We're going to use left, right, opposite just because it's only one rule to remember. And so no matter where we choose, there's going to be a left, a right, and an opposite. So our perspective can be anywhere. That's the advantage of treating it as left, right, and opposite as opposed to A, B, and C, because then you've got to remember all three of those scenarios. The last case, B, was isolated only because that problem lent itself to that. So let's find A. So let's fill in what we know here. We know that the opposite side from A is going to be $50.7. That's right, 50.7 squared. That's going to be equal to the left side squared, which is 45.2 squared, plus the right side, the only one left, 31.0 squared, minus 2 times the left times the right times the cosine of A. Okay, well, now there's a little algebra to do. We got to get A solved for A. So we should take 50.7 squared, subtract off 45.2 squared, and 31 squared. So if you take 50.7, what I've done is just I've shifted 45.2, subtracting it off of the left sides, taking the 31. 50.7 minus the 45.2 squared minus the 31.0 squared leaves you with on the right side, we've got negative 2 left, right. Negative 2 times 45.2 times 31.0. Stop there for just a minute. Make sure that you agree with everything there, at least that you follow. I condensed a couple of steps here. Subtracting those squares off from the left, working out what that numeric value is, combining all these factors on the right. Well, we're almost there. What's next? Divide by negative 2802.4. Again, watch the sign. That's the most common error. And the cosine of A works out to the negative signs cancel, and we're left with 0.1541. Okay? Now again, cosine, there's no question. If A turns out to be an acute angle, this is going to be positive, and we're going to have our angle in the first quadrant. That is to say 0 to 90 degrees. If this turns out to be negative, then we're going to be over in the second quadrant. Our angle would be, just a quick review here, remember that cosine, we're talking about cosine. Cosine is positive here in the first quadrant, but cosine is negative over here in the second quadrant. So if we get a positive value down there, that means that we're over here in the first quadrant and angle A is less than 90. It's acute. If this value turns out to be negative, then we must be picking our angle out of the second quadrant, which is between 90 and 180, and angle A would be obtuse. You never have to worry about it. Your calculator takes care of it this time. So what does A work out to be here? 81.1 degrees. It's positive. First quadrant, 81.1. It's acute. Okay, stop there for a minute. Now you've got a foothold. Now you know an angle and the opposite side. Both of the cases where we need law of cosines is in a case where we can't use law of sines. We don't know an angle and an opposite side. Now we do. There's no need to use law of cosines again. Before I erase it and we'll use law of sines to solve another one, questions about that process, or does that look good? Okay, then we know, let's go ahead and find B next. We know that the sine of B over 45.2 has got to be equal to, we don't have any choice, what's this got to be equal to? That's right, sine of 81.1 degrees over 50.7. That's the only angle and opposite side that we know. If you go through the trouble of solving that, I'm just going to save a little time here and note that B is equal to 61.7 degrees. So B's got to be 61.7 degrees. That's two of the three angles. By subtraction, then, we can determine that the last one, angle C, is 37.2. And we found all three angles. And we're done. Here's one to do this for practice. I'm just going to give you a couple minutes. No picture here. You'll need a sketch. I just want you to find out what the three missing values are. I'm telling you that angle A is 28 degrees, side B is 4.73, and side C is 6.55. Take a couple minutes, make yourself a little sketch. Finish that out. Gabe. Okay, well, let's take a look. Your first step, there shouldn't be any variation in. We'd all have to do the same first step. You know, side angle side. We have no choice but to use law of cosines to find the opposite side length. So we know that opposite side would be A. A squared is equal to 6.55 squared plus 4.73 squared minus 2 left right, cosine of 28 degrees. If you solve that, you get A equals 3.25. Everybody get the same thing there? Okay? Yeah. There's no variation there. Now the second step, that gives us this side. The second step is to use law of sines to either find angle C or angle B next. Now how many of you chose to find angle B next? How many of you chose to find angle C next? Angle C, you can do either one, but you have to be a little bit careful. Here's a rule that will tend to lead you out of trouble. If you find angle B next, we get 43.1 degrees. By looking at this triangle before you even started the problem, or well, actually after we know 3.25, what angle is going to be the biggest one here, A, B, or C, just by looking at the side lengths? C is, because it's opposite the longest side. Is there any chance that C could turn out to be obtuse? There is a chance, and in this case it does. If you use your calculator to find C, your calculator will only tell you an acute angle, though. Did you find that, Grant? Did it tell you that it was like 70-something? 71.1. And you can't rely on that. You have to go through and figure out, well, is it that one, or is it its supplement, the one in the second quadrant? When you're faced with this situation where you've got to decide which angle to find next, always find the smallest one next, because you know that one of these two has got to be acute. You can't have a triangle with two obtuse angles. So you find the smallest one because you know the smallest one has got to be acute. So if you choose to find B next, you get 43.1. There's no question. It's got to be 43.1. It can't be obtuse. And then there's no question about C because you find it by subtraction. So when you're finding more than one angle, the general trend is to find the smallest ones first and work your way up to the biggest ones. Find the biggest one by subtraction and you'll never run into that. So B is 43.1 degrees, and then by subtraction you find out that angle C is 108.9.
By smallest to the smallest
Smallest angle measure, which is always going to be opposite the smallest side length. Like just by looking at this picture, we know that since 3.25 is the smallest side, angle A has to be the smallest angle. When these two are left, that's smaller than, this is, let me try that again. This side is smaller than that one, so this angle, B, has got to be the smaller angle. So we use law of sines to find that one. Okay, and we're done. We've exhausted all the cases of triangles now. There's nothing that can arise that we haven't dealt with. What I'd like you to do now is just sit back, get comfortable, put your pencil down. I'm going to give you a few triangles. And all I want you to do is decide which of the 6 cases we're given. Are we given angle, 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 side, 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 angle, side, 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 angle, side, and so forth? Based on that, which law would you use to get started solving it? Law of sines or law of cosines? Here's the first one. Just think about it for a minute. I'll give you a couple of seconds to think it over in your head, and then we'll discuss it. There's the first one. 2 things. 1, side, side, sides, side, angle, and so forth, and then what law to use. It's ASA, right? Angle, side, angle. 2 angles and the side in between. And angle, side, angle, you use law of sines. Why? Because you can find that third angle real easily, and then you know an angle on the opposite side. So it's going to be law of sines. Next one. I'll just have you, when you realize which one it is, just hold on to it for a second. Give everybody else a minute to look it over and make a determination. What about this one? Think about that for a second. Well, that one's pretty straightforward. It is side, 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 and so you are going to use law of cosines. That's right. Agree? Okay, next one. What have you got? It's angle, angle, side, right? Angle, angle, side. We got 2 angles and a side that's not between them. And since you know the 105.1 degrees and the opposite side of 35 feet, you would use law of sines. That's right. Next one. It is side angle side, two sides, the angle in between, and if it's side angle side, you're going to use law of cosines. That's right. We don't know an angle on the opposite side, so we can't use law of sines. Next one. You have angle, 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 and you should use no chance. You can't solve it. We need to know at least one side to determine the size of it. We could have dozens of different triangles that meet these criteria, some small, some big. We've got to know at least one side length. And this one. This one is side-side angle. Side-side angle, we know two sides, the angle is not in between. So you'd use law of sines, and that's the one to watch out for. That's the case where you need to run the tests and decide whether or not there's more than one possibility.